That was an excellent presentation. Ultimately, he told very clearly, find the worst points and fly the worst point and try to bring down the 10,000 test points to single. Otherwise, we will be doing the flight test forever. Thank you, Mr. Rignall. We are running out of time. Our last speaker is General Bach. He was a former Chief of Air Staff in Germany. He graduated from the secondary school and joined the German Air Force in the year 1965. He subsequently attended the General Officers Staff Officers course at the Federal Armed Forces Command and General Staff College in Hamburg from 1978 to 1980. Within the Air Force, he rose almost every level, and he was appointed as a Vice Chief of Staff, Chief of Air Staff in the year 2000, before assuming the post of Chief of Air Staff in the year 2001. He also holds the Cross of the Order of the Merit of the Federal Republic of Germany, first class, and he has assumed the appointment as the Commander-in-Chief Allied Forces, North Europe, on 15 January 2004, with the change of headquarters name on 1st July 2004. He became the Commander Allied Joint Force Command Bristol. He has flown most of the aircrafts. In fact, before the conference started, he started a little late. He was explaining us how he was flying the MiG in those days. He has more than 3,500 flying hours on different jets, but most of them are the Phantom F4. He is going to talk about total cost of ownership and planning. Thank you.
Whenever you need my support, Mr. Chair, First of all, Mr. Chair, I hope you don't expect me to catch up with the time, because otherwise I would have finished approximately 12 minutes ago. So I want to congratulate DRDO for setting up this extraordinary conference. And at the same time, I want to thank for the invitation to give a presentation to such a distinguished audience. But before I start out with my presentation, I must give a minor but nevertheless very important correction to the curriculum vitae you just listened to. Unfortunately, I'm not a commander anymore since I retired 3 years ago. The command position has been taken over by my wife. And now I am only a senior advisor to the German Ministry of Defense, and so I'm here as its representative to this really extraordinary conference. So thank you very much. And just one word before I really start out. Professor for pilot, and I suppose Ola is agreeing with me, it's always frightening if you listen to somebody speaking about UAVs, because this gives you the very strange feeling that you are replaceable at the most wonderful working position in the world, in the cockpit. But I suppose, Professor, that's the future. Total cost of ownership. Lifecycle cost, and all related terms are often discussed, but seldom with a common understanding. My presentation, consisting of 2 parts, details firstly with general considerations of cost of ownership of military aircraft, and in the second part with the experience I have garnered during my professional life in the German Air Force, especially as Chief of the Air Force, many focusing on the latest generation of combat aircraft, in this case, the Eurofighter. Beginning with the question why TCO is so important and why the comparison of figures of different aircraft and manufacturers is so difficult, it is fundamental to understand what terms like flyaway cost actually means. And sometimes, I know you I suppose you know this Babylonian confusion about languages. And sometimes you have the impression, talking about total cost of ownership, there is Babylonian confusion of language. Further, I'll demonstrate the main influences, factors of total cost of ownership for the different phases of a platform life cycle, which conclude the initial and general part. In the second part of the presentation, I highlight my experience in the German Air Force, where the main focus lies on the ownership of modern and complex weapon systems. It is particularly pertinent to the debate because the German Air Force owned and operated a mixed fleet of European, American, and Russian combat aircraft, and this makes it possible to compare total cost of ownership on a very broad basis. And I suppose this also reflects the experience, at least in parts of the Indian Air Force. Out of this experience, the latest development in the German Air Force is a system of cooperative models, how we call it. We regard this as a very efficient and effective tool. And I will explain how this model works and the benefits of a shared system support. This means a true partnership between private industry and the military on eye level in a win-to-win situation. The iceberg on this picture presents perfectly the problem of the cost aspects. Everybody sees the price for the flyaway aircraft, but nearly nobody looks underneath at the following support costs. So always looking at the lowest costs of acquisition is, as we know it nowadays, the wrong way to do. Everybody sees the price for the flyaway aircraft, but as I said, nobody looks at the following support costs. But these are the real big numbers, as was already mentioned by Professor Pali, by Dr. Pali. But these are the real big numbers summed up for the whole life cycle. And we talk about the life cycle of a weapon system nowadays. We talk about an operation of 40 to 50 years. And this is a reason why transfer of technology is so important, and not just offering offset. The other important aspect of building up a modern air industry for self-reliance and autonomy is national autonomy and national decisions. To determine total cost of ownership, it is necessary to take a comprehensive calculation. As we operate modern weapon systems, as I said, for decades, and you need to know how to calculate your budget and how to use it in these years to come. Here we see the different types of cost terms. It is one reason for confusion that many numbers are available. But needless to say, that sometimes this confusion is caused deliberately. So it's very important when anybody talks about those terms that to really ask what is being meant, so that you are sure what really is on the price list. And in each term, it's depicted what we understand out of it. This slide shows the graphical distribution of cost during the product lifetime for an indigenous development. Summing up, the in-service costs becomes obvious. It becomes obvious that those are the biggest portion. As here the development costs are also shown, this distribution applies to an indigenous in-country development. Buying an aircraft reduces the first portion, but it reduces also the possible influence on the result. your influence on the design of the aircraft, as was mentioned by a previous speaker. And I'll come to this later. Secondly, it is necessary to understand that early investment that lead to reduced in-service costs really pay off. And this is also shown on this graph. Just for explanation, the total cost of ownership includes the acquisition costs, including development, production, assembly, delivery of aircraft, engines, spare part, ground support, equipment, simulators, and so forth. The operation costs, including POL, operator, pilot costs, including training, simulator operation costs, number of flight hours, operational procedures. And those are the only numbers US Air Force can influence. Support costs, of course, also, including military and industry maintenance, as well as sustaining technical and integrated logistic support, infrastructure-based concept, and the capability, maintenance improvements, integration of additional capabilities, further development, maintenance concept. Just for your understanding, in the upper part of the slide, RMT means reliability, maneuverability, and testability. The biggest impact on the total cost is clearly, as I mentioned already, in the definition and development phase of the aircraft. By then, only very little money has been spent. Those are the design factors. Material, aircraft systems, engines, 1 or 2, software, growth potential, performance, safety, reliability, maintainability, and testability. And then it goes into the other direction. An early decision like the number of engines determine a big portion of the total cost of ownership, but it also determines the safety factors that you contribute to the aircraft. And we of the German Air Force, we have experience with single engine and twin engine aircraft. So we know what we are talking about. In the production and in-service phase, only less cost can be influenced because the factors are hard factors, as I mentioned before. They are set. Flying hours, support, service, logistics, and so forth. Also, you have possibilities, as I will show in my briefing, where you can reduce those numbers. A short calculation showing the level of easy maintenance, where we have really put our emphasis on, saving only 20 man-hours per flight hour, is that over the lifetime of an aircraft, you save 1.8 billion euros. But this is, of course, calculated on the basis of that one man-hour would cost 100 euros. That's the calculation we have in our Air Force. So it might be different from country to country. But nevertheless, I think it's an impressive number at the end of the day per aircraft. The German Air Force owned and operated a mixed fleet of European, American, and Russian combat aircraft, as I said before, and this gives us the opportunity to compare total cost of ownership on a broad basis. Out of this experience, we have decided to specify our latest development, the Typhoon weapon system, with requirements keeping the balance of being an extraordinarily capable aircraft at affordable costs. And I really say affordable cost, also the acquisition cost seems, looked at it from the outside, seems to be high. But as I said before, you have to look underneath the surface to consider the iceberg, because otherwise your calculation is wrong. Some major decisions are shown on the next slide. With regard to the design, lightweight, non-hazardous material, which nowadays is very, very important with regard to the environmental aspects, fail-safe operations, twin engines, modular, redundant systems. the lifetime 6,000 flight hours, aircraft and engine without overhaul, a high safety factor, growth potential with each regard, and as I mentioned before, reliability, maintainability and testability have been given equal priority in the design. And on part of the slide you can see how the RMT effort really and the design effort really pays out. If you take the light blue is legacy weapon systems and the dark blue are new weapon systems, and you see really the operational costs going down. And this, calculated over a lifespan of, let's say, 40 years, gives you an incredible payoff. The graphic shows, like in a business case, that early investment in RMT pays off in later stages of the life cycle. That's what I said when I said that you have to look down the future and not just at the point of time of acquisition. This details the latest aspect I mentioned. Having a reliable weapon system is the basis. And in case of failures, it is easy and quick to repair. Because as an operator, you want to have the aircraft back as soon as possible to get it back into operation. We specified in our specs that we would allow 400 primary defects, less than 400 per 1,000 flying hours. Right now, in the German Air Force, we achieved already 280 or less than 280 primary defects per 1,000 flying hours, and we expect to go further down with this number. We expect around 200, 220, gaining more experience with this weapon system, and I think this is achievable. In the background picture, you can see a mechanic reading out the maintenance data panel, which is the central access of our maintenance crew on this aircraft. Digital interfaces to the electronic lookback eliminates many human errors because they have hard criteria. Looking in the future, we see options to reduce the cost even more. But already now we have considerably reduced our investments for training or infrastructure, for example. And I come to that later, how we achieved it. But there is still room for improvement, as there is always room for improvement. What we also improved are the inspection intervals per lifetime. And the slide depicts our experience with the various weapon systems we have operated. At the top, the F4, where we had 39 intervals per life cycles, inspections intervals per lifetime, with a midlife upgrade. The most expensive weapon systems we ever operated, the MiG-29, which we only gave 3,600 hours to fly per life, where we had to make a life extension and a TCI on the engine. On the Tornado, we made 19 inspection intervals per lifetime, and now on the Eurofighter we have 14. And this really shows the improvement we went through. And this really shows also that it pays off on a long time. And it's very important that we do not have to make a midlife upgrade, because midlife upgrades are really expensive. And the operational value you get out of it is always very limited. Our philosophy for support has changed after the end of the Cold War. Additionally, to the political change, the budget restrictions became bigger. And I think this is not just an experience in the German Air Force. Budget restrictions, everybody is suffering now under it and gets it. Now our concept is to integrate the military and civil industrial capabilities into cooperative organizations. We regard this a very efficient way to support our weapon systems. And we even made these cooperative models now with the Tornado. Also, we have it much longer in service. A precondition, however, is a technologically advanced industry. And again, I stress what I said before, that whatever you do now, that you look at transfer of technology and not just at offsets. If you want to have an indigenous, self-reliant industry, that's one of the preoccupations. It's not done from now to tomorrow, but you have to start with it. Because otherwise, you will never get it. In this picture, the different cooperative models are shown, and what we still do in our wings. So in the wing level, we just do the on-craft aircraft maintenance and limited off-aircraft work. The rest we do in cooperation with our industry, mainly in Manching, where we have set up support centers. And in these centers, the military, my personnel, or my former personnel, is working alongside the engineers and the technicians, alongside with the civil ones. And this is very, very efficient. It saves money, and it saves personnel. The benefits for the German Air Force you can depict out of this slide. We have less investment in infrastructure because we use the infrastructure together with the industry. We establish a system know-how to become an intelligent customer, so that industry does not tell us what we have to do, but the other way around. And there's an exchange of ideas, a vivid one, which really pays off. We have availability of adequately skilled and experienced officers for out-of-area engagements. Out-of-area engagements is something we have to look for in the future. And as you might know, at least in my nation, we only can deploy into areas, into war areas, soldiers, not civilian personnel. That's why we have to train also our military technicians so that we are able for out-of-area engagements. The benefits for the industry is a participation in all system support tasks, including software maintenance. And they know how we think, and we know how they think. And this is very important. And we have for both a real win-win situation. And my recommendation is for the Indian Air Force and for the Indian industry, and you listened yesterday to Mr. Anand Mahindra, who really stressed this also, to set up such a win-win situation between the military and between the civil industry. But again, you have to have the knowledge about the technology, and not just the knowledge about black boxes being delivered. The common benefits, we don't have any duplications. We have established a national system support capability, and we have a provision of fast operational support whenever required. In concluding, total cost of ownership is a very important discriminator for every modern weapon system. And if somebody talks about total cost of ownership or life cycle costs, you better ask, what is his understanding about this? Because otherwise, you might have wrong numbers. Care to be taken when comparing TCO. That's what I said. The user affects his own total cost of ownership through in-service and industrial concepts. So you have to be involved from the beginning. You have to be a true partner in a cooperation. A true partner. And a special consideration has to be given to RMT because of the follow-on costs if you operate weapon systems for more than 40 years. So this is the experience I can give on to you, or let's say to the younger generation. But again, I think that this is a path to future. Thank you very much.
So with your experience, can you say how percentage, what would be the percentage of RMT in giving benefit to the total cost of ownership?
Well, right now I could not give the formula, how much it is. Whether it's 20%, whether it's 30%, that's what your question is.
Correct.
I only can say, and this is depicted on the slide, that it's a substantial part. Because reliability, I suppose you are a pilot, reliability, maintainability, and testability is where a lot of man-hours are hidden behind. And on the other hand, if the reliability is not given and the maintainability, it takes the aircraft out of the operational envelope and out of your possibility to operate it.
But in other way we can say, if I make a aircraft more maintainable, which you showed in Eurofighter, where one technician is looking from that all the parameters of maintenance, will it not eat away into the operational capability of the aircraft because you are putting more infrastructure onto the aircraft for maintenance purpose?
No, what I'm saying with that is, the more reliable an aircraft is, and the less maintenance I have to put in the aircraft, the less costs are existing, right? And that's what I'm pleading for. That's what I said. That we were looking at the reliability of the aircraft, of the airframe, and of the engine, and also, of course, of the electronic systems. That we were looking at the maintainability, an easy readout of failures if they exist, and the easy possibility to repair. That's what I mean with this. And that's where we put our emphasis and our thoughts in when we designed the aircraft, when we designed the structure, when we designed the engine, when we designed the whole system. But I could not say to you right now that would be cheating whether it's 20% or whether it's 25%. But it's a considerable portion of it. That's what I depicted on the slide.
Okay, thank you, General Beck. Chairman Organizing Committee is getting jittery because it's getting delayed.